Okay, problem 6. So what's going on here is we have this laser light that's incident on this stack of blocks. And so the air it's in originally has a refraction index of 1, and then there's a bunch of other slabs, and then the final one has a refraction index of 2. I have not written in the refraction indices of the other slabs because it doesn't matter. So here's what I'm going to show you. Theta 1 is going to be the angle in medium 1, which is the air, and that's just 30 degrees. Okay, and so Snell's law says if we want to then go and find the angle it goes at with respect to the normal in medium 2, we say, no, we don't do theta, sorry. We say n1 sine theta 1 equals n2 sine theta 2. Lucy, I need that. I'm sorry. Okay, that's one of our cats. Well, still kittens, but they're like 8 months old now, so they're getting big, but they still like to play. And Lucy's attacking my pen, clearly begging for attention. But anyway, so n1 sine theta 1 equals n2 sine theta 2 is Snell's law for this boundary here. Okay. Now, if I want to go and do the next boundary here, and then go to find what sine theta 3 is, then what I do is I say n2 sine theta 2 equals n3 sine theta 3. And then for the next one, n3 sine theta 3 equals n4 sine theta 4. Now, what the astute observer will have noticed by now is that these two terms, or these two sides of the equation, well, two terms, right? The n2 sine theta 2 term, I'm sorry. Let me start again. The n2 sine theta 2 term repeats here and here. The n3 sine theta 3 term repeats here and here, etc., etc. And so you can see this is going to progress all the way through all these until you get down to the bottom. And then after 6, there's no more layers, so that's the last one, right? So n1 sine theta 1 equals n6 sine theta 6, okay? So now you actually have a very easy problem because it's just this one equation. So n1 was 1.00, sine theta 1, sine of 30 degrees, 0.50, equals, and then n6, 2.00, sine theta 6. And so, let's see, what you get is theta 6 is the inverse sine of 0.25, or 1/4, because it's half of 1/2. I don't have my calculator, I'm not going to figure it out, but it's like 14 point whatever. Okay, so, but anyway, that's the answer. So that's sort of the trick I wanted you to see, is that when you have these layers, and the reason that it works is because these interfaces are all parallel. If they weren't parallel, it wouldn't work. So only when these layers are parallel can you do this, but when that's true, you can skip from the beginning right to the end. Okay, kind of a neat little factoid. And I'll move on to number 4 after this.